Okay, so hopefully you've got your head around the resting membrane potential, and we can move on to things called local potentials. So here we have our neuron, and it's sitting at -70. Okay, so I'm just going to try and draw. So we're sitting at -70 millivolts. That's the resting membrane potential. So for example, I added some more positive ions, some sodium ions into my neuron, then that -70 is not going to stay at -70, is it? That -70 is now going to turn into another value. It's going to be -60, or it's going to be more positive, okay? All we're looking at is this area of the neuron here. It's going to be more positive, okay? So let's add a few more sodium ions. Oops. A few more sodium ions into our neuron. And now, all of a sudden, instead of being -60, now it's gone up to -50, okay? So what I want you to understand is that you can add sodium ions into the cell body of a neuron, and that's going to make the neuron more positive or less negative, okay? Now, there is a little, from this point onwards, there's actually another protein that I would like to introduce you to, and this protein is called the voltage-gated sodium channel. Now, normally, this protein just sits there in the membrane and with its door being shut. So if I were just to add a few of those in there, okay, they sit on the plasma membrane of the axon, okay? They sit all the way along it, all right? Now, these protein channels, these voltage-gated sodium channels, they open only when the neuron hits -55 millivolts. When the neuron hits -55 millivolts, then all of these channels here start to open, okay? So normally at -70, they're closed. When you hit -55, then all of these lids start to open up. Okay, so this is just a picture here of that, all right? So you've got, this is the area where it's triggered. So this little area here has to hit -55, and then that's when you get the sodium, voltage-gated sodium channels opening. All right, so this is what we're going to learn about now. We're going to learn about the action potential, okay? So here is our neuron sitting at -70. If you add more and more positive ions, eventually it will get to -55. Okay, so let's think about what it is, what the action potential is. So we know that the neuron is sitting at -70, and if we add positive ions to the cell body here, we can shift it from -70 to say -55. And we know that at -55 is when these voltage-gated sodium channels open, okay? Now what happens when these channels are open is that you have these sodium ions entering the neuron, okay? When the sodium ions enter the neuron, they are positive. So they're going to make our neuron more positive or less negative. So that is kind of happening here, all the way up the top. See? That is all sodium going into our neuron. The next thing that happens is that those voltage gated sodium channels close. Okay? And that happens kind of at number 4 here. At plus 30 millivolts, the voltage gated potassium channels open. Okay? And then what happens there is that potassium then leaves my neuron, and positive charges leaving the neuron will make the neuron more negative. Okay? So that's what you're seeing here. All right? Now, the neuron becomes slightly more negative because those voltage gated potassium channels, they take a little while to shut again, and so we lose a bit more potassium than what we normally should have in the cell to begin with. Okay, that's that hyperpolarization. So if this is 0, so depolarization means that you're moving away. So you're moving from this negative pole. So this is depolarization, and then this is repolarization, and then this is hyperpolarization. Okay? It's all about sodium and potassium moving through channels that are open using different voltages. So they open and then they shut. Okay, so what you can see here, this image is just showing you that this is the voltage gated sodium channel and the voltage gated potassium channel. And at minus 70, nothing happens because we've only got the leaky channels and the sodium potassium pump that are working. This is when the voltage gated sodium channels open. So as sodium comes in, our neuron becomes less negative. And then those sodium gates close, and now the potassium ones open, and then potassium leaves the cell, making our cell more negative. I'll let you have a look at this video that summarizes the action potential. And just one little thing before we finish off this section. There are 2 kind of refractory periods associated with the action potential. And it's all got to do with the sodium channels, okay? So minus 55 is when you get the voltage gated sodium channels opening, so we know about that. And they open, but the voltage gated sodium channels open and then they shut, okay? And when they shut, they become deactivated. And it takes about 1 to 2 milliseconds for you to be able to open up that channel again, okay? Doesn't matter what you do, you're not going to be able to open that voltage gated sodium channel for at least 1 to 2 milliseconds. After that time, okay, the sodium channels come out of activation, which means that they can be opened again, okay? So just keep that in mind, that the voltage gated sodium channels open, shut, they're locked, and then they are ready to be open again, okay? So they have like a bit of a locking mechanism. So open, shut, lock, 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 okay, I'm ready to be open again, okay? So that 2 millisecond onwards is called the relative refractory period, because some sodium channels become unlocked and you can now are able to be opened again, okay? So it's not deactivation, it's more like locked. You cannot open it again, and then here it become unlocked. So become deactivated, locked. So when it's locked, you cannot open them again. When it's unlocked, they are able to be opened again, given the right voltage. Okay? And that's it for that part.